Hello. So today we'll be working on generating names with char level RNN. So today we'll try to implement the Pytorch tutorial one, which doesn't use, which creates its own RNN. So we'll also try to change it so that we can use the RNN provided by the Pytorch, and we'll also run the Pytorch execution graph. Yeah, so in this so as we are seeing, this code is mainly common, so which means here we can use the complete process. We just need to change model. So right now we have 3 models or 2 models. There should be 2 models. This is raw, which we created. This is old one, which we can delete. I think this is the old one. This is 2 months old, so this we can delete. So right now we have 2 models, model Pytorch and model Pytorch RNN, and ideally it should be scratch. So this is the file which we can use, so maybe we can take it out. Okay, and this is our RNN. So this we may need to create again. All these functions are common. So fit model is again, I think, mostly common. Let's see how we can reuse most of this stuff. So let's just try to maybe create here only. Yeah, so what we are doing here is we are trying to make the changes in the char RNN classification itself, as a lot of things will be common. So what we have done for now is, we in char classification we had this processes of the util function. So we have created a new file, new Python file, and we have put the changes which is required. So what they are doing is, they are saying that they are creating a category one hot encoder and will pass in every input. So what they have also said that it's a design choice, we can pass that in so where it is, yeah, so we can pass that in an initial hidden state or some other strategy. So what we'll do is, we'll first try to implement their solution, and on top of that we'll try to make changes so that it's a part of initial hidden state, so that then we can just use the older RNN. I feel we don't need to like pass category in each input, because at the end it's the same category you are passing. So yes, so it's just a one-time input, so you can pass it in a hidden state. So now we'll make the changes in the training part and the fit part. So one thing they are saying is, because we are using obviously the magic of AutoGrad, what we are doing is, we now, earlier we were just calculating because we are only interested in the last output, we are calculating the loss at the end, but here we are calculating the loss at every step, and when we run the backward, it will try to run backward on each of these values. So let's see the pathing execution graph. That will also help us in giving an idea. So let's just do that. So names are getting complicated. So these were our previous RNN.py. So we have created train, char, gen, RNI. So maybe we should rename that as well, so that it's in sync. Train, char, classification, RNN. So now it will remain the same. Utils is also, maybe we can just rename it. We have just created it to B. So let's just do the processes char gen. So it will be along with this. Now it looks much clear. Okay, so initially I thought we'll just make it more modular, but because we are just doing the Char classification, maybe we'll just do a copy paste, and we'll try to later on maybe we can merge, or we can make it same, or maybe we can just pick as things comes. So we'll just do, so instead of processes we have, okay, from, it's not just taking I just copy paste. Okay, here model is also we are using this copy relative path. Even the relative path is big. My god. So we are not using this right now. We'll do it when we'll implement this in using pure including in using Pytorch, and then we'll do that. Okay, rest, let's let it be, and then we just need to first see a single training model how it's working. Hidden layer, so how many hidden layers we have created? Where are we passing the hidden layer? At 120, it's the same hidden layer, so let's just do, just copy this. We'll change this later on, we'll create our own. So let's see what we have to pass here. We have to pass input size, so we have to pass input size. Yeah, so input size our n letters. Okay, hidden layer is here. Output size, so what is the output size here? Output size is created an output size. Okay, output size is the hidden, output size is actually the category size. So if we see that earlier the output size was to predict one of the categories, but now here we have to predict one of the outputs. So ideally the output size should be the input size, because we want to predict one of the values, we don't want to predict the category. So let's see what we are passing here. We have created RNN, but where we have initiated is instantiated it. Anyway, let's do it ourselves. And letters and hidden size and hidden output size should be again and letters, and then and my and categories, which is the categories I'm passing. So let's add the train. So criteria is again n loss, so we still have to read more on that, but for now let's just add our learning rate and criteria, and then let's add the train function. Yeah, so here we see, right, they have created again the same way, input and the output as of the same values, because we want the same output. Cool. So we have defined the train function. So in the train function, let's also so here we are also putting the charts. So let's put the charts as well, mainly the output chart we are interested in. Let's do that. Let's just do for the loss. Dot join path loss graph, or we can just do it here. Don't need to do that, we can do it loss graph char generation. Okay, so put it at this, put the breakpoints. This looks the same. Now let's also create our fit function and put this code there. Save data will do later. So I think for now let's first run it and see how it works. So we here will call classification generation. So at the end we'll call the fit. So we'll also see how it's working. I'll just put the break here.